Hello everyone, welcome to the session of Class 6 Mathematics, and I'm your Anu again for mathschool.1. Actually, we have left in the last class until fractions to decimals, isn't it? So I just want you to make a note at this point. So please have a pen and paper with you always so that you can note down the tips or the hints or some specific points I tell you in between, because that will help you when you do revision and that will make you remember certain things. Okay, so with that note, we'll start with today's session. So where were we? We saw fractions to decimals last class, isn't it? So just have a recap. Fractions to decimals. We know fractions. So I said 2 by 5, 6 by 10, 3 by 4. So fractions to decimals, when we are speaking about fractions, we know they are not whole numbers, they are part of whole numbers, isn't it? So they are some part of whole numbers, and we just want to represent them, we just want to represent fractions in numbers. That means not by this form, that is P by Q form, that is numerator by denominator form. We have to, we want them as a number. Okay, so that is what I said last class. Decimals are numbers which represent fractions, that is, which represent parts of a whole, isn't it? So we have a whole number part, a decimal point in between, and then the decimal place. Now, while changing fractions to decimals, I told you there are two methods to change fractions to decimal. That is, one is by direct division. By directly dividing, putting point and then adding zeros to the dividend, we have the decimal numbers as quotients. And the other method I told you is by converting the denominators. If you can convert the denominators to multiples of tens, then that will be very easy for us to find the decimal equivalent for the fractions. So let's do these three numbers. Okay, so first is 2 by 5. I do by normal division. So 2 is not divisible by 5, isn't it? So I put a 0 and put a point to it, next to it. Okay, so whenever I see the dividend is less than the divisor, I just put a 0 and then a point next to it. Okay, so by adding a point next to the quotient gives us a privilege of adding zeros to the dividend. So which means when I put a point here, I can add 0 to this number. So 20, I have 5 4s are 20 now. So the answer is 0.4 is your answer for 2 by 5. So you have got the equivalent, decimal equivalent of 2 by 5 fraction. So in the same way, I divide 6 by 10. So 6 is not divisible by 10. So I put a 0 here and then a point. I add 0. So 0.6 is my answer. So for 6 by 10, it is 0.6. Now for 3 by 4, again 3 is not divisible by 4. So what should I do? I should put a 0 first and a point. So upon adding a point, I can add 0 to this number. 4 7s are 28. So 2. Next, I have added a point here in the quotient. So I can add zeros to the numbers. Okay, so 20, 4 5s are 20. So that is how I get 0.75. Now this is one method. The other method which I told you is converting. If you can convert the denominator to multiples of tens, you can. So 5, I can convert it into 10, isn't it? How do I convert? 2 by 5. I can multiply it by 2. So, but whatever operation we do it in the denominator, we need to do the same operation in the numerator too. Or else the fraction gets changed. Because 2 by 5 is not equal to 2 by 10, isn't it? That becomes 1 by 5 when you convert it into the lowest form. So whenever I multiply a number or divide a number in the denominator, the same operation has to be done in the numerator also. So 2 into 2, that becomes 4 by 10. Now this gets reduced when I convert this 4 by 10 to its lowest form. It becomes 2 by 5 again. So the fraction doesn't get altered. See, 4 by 10 is your answer. Now, upon seeing the denominator, I have multiple of 10. So, having a multiple of 10 in the denominator helps me to find the decimal equivalent more easily. How? Because see, I have 10 here, I have 1 0 in it, isn't it? So, what should I do? I told you, write the quotient as it is. Write the numerator as it is. If there is 1 0, start from right and move to places. How many places? As there are zeros here, number of zeros here. So there is only 1 0 here. So from right I start and put a point here. Only one place. I need to move only one place because 1 0 is there. 0.4 is same as this. Okay, now do you understand? So that is how. So 6 by 10 is, as such, you have 10 here, isn't it? So there is only 1 0 here. So from right I keep a point here. This is 0.6. Now the third one is 3 by 4. What about 3 by 4? How do I convert 4 into multiple of 10? So 10 is not possible. The next multiple of 10 is 100, isn't it? So I can change it into 100. So just keep tens, hundreds and thousands. You just try to do it in that way. If you take 20, 30, 40 and all, you need to divide the number by again. If 20 is taken 2 into 10, so you need to divide the numerator again by 2, so that becomes complicated. Okay. So 4 can be changed into multiples of 10 by multiplying it by 25. Yes, 25 into 25, because 4 25s are 100, isn't it? 75 by 100. Now you can see 100 has 2 zeros in it. So how do I convert this? 75, write the numerator as it is. See how many zeros? 2 zeros are there. So start from right, go 2 places towards left. So 1, 2, I keep a point here. So 0.75 is your answer. Do you understand? So this is how we sum up the methods of converting fractions to decimals. Okay. Now the reverse process. How do we convert decimals to fractions? Let's see. How do we convert decimals to fractions? Now let's take 0.5, 1.06 and 32.5. So I've taken 3 numbers here. So let's start converting these decimal numbers into fractions. So keep one thing in your mind. Whenever we convert decimal numbers to fractions, we have fractions. That is, we will be converting the decimal numbers to fractions anyway. But after getting the fraction, do remember, make them to their lowest form. Bring them to their lowest form. So that will be the exact. Anyway, whatever you change to fraction, that is also has to be equivalent to this decimal number. But keep it as a practice. Do keep it as a practice. After converting decimal number to fractions, make the fractions to be in its lowest form. Okay, so that I'll show you how to do it. So now 0.5, 0.5. What I said, what were we doing before? Just writing the numerator and then adding point, isn't it? The same way, just write the number here. Whatever number is given, you can write. See, 0.5 we can't write. I mean, it is not possible, isn't it? 0 doesn't come in the first place. So it has no meaning too. So instead of writing 0.5, I write just 5. So write just 5. Okay. So now how many places after right the decimal point is? Only one place is there. Okay. In decimal place, there is only one number. So what I should do is, I should put only 10 after 1. Okay, do you understand? So 0.5, 0.5 can be written as 5 by 10. Now just check the answer by converting the fraction back to decimal number. So 5 by 10, how it can be converted into decimal number? I told, just write the numerator alone, then see how many zeros are there. 10. So from right you move one place towards left, so 0.5. So that is absolutely right. Now this is 5 by 10 is equivalent, fraction which is equivalent to 0.5. But what I told you is, you need to convert this 5 by 10 to the lowest form. Okay. So 5 by 10 can be converted into lowest form. How do we convert it? We need to divide the numerator and the denominator, both numerator and the denominator, by the same number. Okay. So 5 by 10, so it divides, 5 divides, so 1 divided by 2. is divisible by 5. So 5 ones are 5, 5 twos are 10, 1 by 2. So this is the lowest form or the standard form for this fraction, and 1 by 2 is the answer for 0.5. Now do you understand? Now the next one is 1.06. Now what we need to do is, the first step is write the number as it is. See, 106, write the number as it is irrespective of the decimal point. Okay, you write all the numbers together, 106. Now what will be the denominator? You have two places in the decimal numbers, so 1 followed by 2 zeros. That's it. Okay, so 106 divided by 100 can be converted into its lowest term by dividing it by 2. Okay, because these two are even numbers. Let's start with 2. So 53 divided by 50. I've got 53 divided by 50. Now 50 and 53 doesn't have any common factor because 53 is a prime number. So I just divide 50 and I divide 53 by 50. Okay, when I divide 53 by 50, I get quotient 1 because 50 ones are 50. The remainder is 3. So 3 divided by 50. So this will be our answer. 3 by 50 is the fractional equivalent of 1.06. Actually, you can leave it at this step also. 53 by 50 is also right. 106 by 100 is also right. But keep it a practice to convert this fraction to its lowest form, as low as possible, as standard as possible. Okay. So 32.5. The next one is 32.5. Now what is the first step? I should write the numbers together. So write 325 as it is, divided by how many places are there here? The numbers are there in the decimal place, only one number. So divided by 10. That's it. 325 divided by 10. I can divide this by 5, isn't it? Divisible by 5. 5, 6 are 30. 265 divided by 2. Now 65 divided by 2 can be written in the mixed fractional form. So 2, 3, 32 and a half. So 32 and a half, 32, 1 by 2 is the fractional equivalent of 32.5. Anyway, see logically. Clear? So 32, 1 by 2, 32 and a half, 32.5 are one and the same. So you can see. So both are same, right? So this is how we convert decimal numbers to fractions. Okay, this is the method by which we convert decimal numbers to fractions. Next we are going to see decimal numbers on the number line. This is quite simple, not like fractions. Depending upon the denominator, we divide the numbers. We give divisions between two whole numbers, isn't it, in fractions? But in this case, it's not like that. We can choose our scale accordingly. So let me explain. Okay, so I have see some 0.6, 1.3 and 2.7. So I need to mark these points in the number line. Okay, so how do I mark these points? So I have after point, I have 0.6, here 3 and 7. So what do I do? See, upon seeing 0.6, where does it lie? You should be able to say where the decimal point lies, other in between what whole numbers, in between which two whole numbers the decimal numbers lie. Okay, so upon seeing this 0.6, 0.6, the whole number is 0 here. So this decimal number lies between 0 and 1. And here see the whole number part. Whole number is 1 here. Since it is 1.3, it lies between 1 and 2. And here it is 2.7. So 2.7 lies between 2 and 3. Now we'll mark it. So since it is 0.6 and 3 and 7, so this is an even number and these two are odd numbers. If all the numbers have even numbers in the decimal places, in the question if they give you all the decimal numbers have even numbers in their decimal places, then you can skip 0.1, 0.2, 0.3, we can mark it like that, or you can also mark it as 0.2, 0.4, 0.6, 0.8 and 1. Okay, now I do it as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and this is 1. This is 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, see When I mark, I'll be able to find out where is 0.6, isn't it? So 0.6 is here. Okay, this is 0.6. Now 1.1, 1.2, 1.3, 1.4, 1.5, 0.6, 0.7, 0.8, 0.9. 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8 and go on. It goes on. So 1.1 here, 1.2, 1.4, 1.6, 8, 9 here 2, 2.1, 2.2, 4, 6, 2.7, 2.8. Now this is obvious. So we can mark it as such, isn't it? 1.3. See, 1.3 is here and 2.7 is here. So this is quite easy than the fractions. Marking decimal numbers on the number line is very simple. Okay, so you have to mark it in this way. So we see that as many decimal numbers can be marked as possible. See, for example, if you have 1.13. So how do I mark this in number line? Where does 1.13 line? See, I have marked 1.1 here and 1.2, 1.3, so on. But there are two decimal places here. So to draw this, I need still some more magnified spaces here. So I have 0, 0.1, 0.2, 0.3 and so on up to 0.9. Now 1.1, 1.2, 1.3, 1.4 and so on up to 1.9. Okay. Now I need to mark 1.13. Now 1.13 means, see, from 1.1 how it starts: 1.10, 1.11, 1.12, 1.13, 1.14, 1.15, so on up to 1.19, and then it comes to 1.2, isn't it? So 1.19 and 1.2 again. So now where does this 1.13 lie? It lies between 1.1 and 1.2. So it's obvious it lies between 1.1 and 1.2. So 1.1, 1.2, you can mark it somewhere here. So 1.13. Okay, so you can mark it like this. So we know in between whole numbers there are infinite fractional numbers. Likewise, the fractions are nothing, decimal numbers are nothing but fractions, isn't it? So in between two whole numbers there are infinite decimal numbers that you should keep in mind. Okay, so for every decimal point there are infinite decimal numbers. So for each and every decimal point there is a place in the number line that you should understand. Okay. Now the next one is, after understanding the number line, we'll move on to comparison. Okay, so how do we do comparison regarding fractions? Regarding fractions, what we saw was we studied what are like fractions. Like fractions, the denominator has to be same. So when the denominators are same, we'll be able to compare the fractions. Or if they are unlike fractions, if the denominators are not same, what we did was we found the LCM of all the denominators and then we made them equal. We made all the denominators to be same and then we compared, isn't it? So likewise, we have here like decimals and unlike decimals also. So unlike decimals have to be changed to like decimals and then it should be compared. Okay, so what are like decimals and what are unlike decimals, we'll see. Now 2.6, 1.05, 2.312. Now these are three decimal numbers. As you see, you can see after decimal point there is only one number. Here there are two numbers and here there are three numbers. So if the places in the decimal, if the numbers in the decimal place are not, number of digits in the decimal place, if they are not same, then they are called unlike decimals. So what we need to do is, we need to see where we have more number of decimal numbers after the decimal point and then the rest of the numbers are made equal to it. Okay, so not the numbers, note that, not the numbers after the decimal point, the number of digits number of digits after the decimal point. See, I'll explain. There are 3 digits here after the decimal place. There are 2 digits and there is only 1 digit. Since there are 3 digits, maximum there are 3 digits after the decimal point, I need to convert these 2 decimal numbers also to 3 digits after the decimal point. So this can be converted to 1.050. You just add a 0, it becomes 3 digits after the decimal place. But without 0 also this is equal to 1.05, and with 0 also this is equal to 1.05. So the number doesn't get altered. Okay, so please do not write it like this. 1.005 is also absolutely wrong. So don't put 0, 1 before 1, don't put 0 because it doesn't have any meaning. So it should not be written like this. So 0 added to the right of the numbers in the decimal place, so that it doesn't alter the number. So see, I have added 2 zeros there, so that I have 3 places after the decimal point. Now here 2.312. Now we can compare. So how do we compare decimal numbers? Decimal numbers have a whole number part. See, whole number part as well as the decimal part, isn't it? So first see the whole number part. Okay, so let's assume we are going to arrange these 3 numbers in ascending order. So the smallest number, so for finding the smallest number, see the whole number part. The whole number part has 1 here. 1 is less than 2, isn't it? So 1.050 is the smallest among these 3. Okay, next you have 2 in the whole number part. Since you have 2 in the whole number part, 2 of the numbers have 2 in the whole number part, what we need to do is we need to see the decimal places also. So the first decimal place has 3 here and it has 6 here. So obviously 2.3 is less than 2.6 because we have seen in the number line 2.1, 2.2, 2.3, 2.4, 2.5 and then 2.6. So 2.6 is greater than 2.3, isn't it? So 2.312 is less than 2.602. So like this we compare decimal numbers after converting unlike decimals to like decimals. So only after converting unlike decimals to like decimals we will be able to compare, and we'll also be able to add or subtract them. You understand? So addition subtraction also involves like decimals, but we can add unlike decimals too. So it is not that we need to convert unlike decimals to like decimals for addition and subtraction, but it will be well and good, it will be easy for us without any confusion to make it to like decimals. Otherwise we can just add it like this also. See to that the decimal point falls exactly on the same line. Okay, so the decimal point should be in line so that you won't get confused. 2.312, so that their place values doesn't change. See, like this you need to write. So if I make them as like decimals also, so the numbers won't be altered, but it will be easy for us to calculate, we won't get any confusion. But see that the points all fall on the same line. Now this is 2, if I add 2, 9, 4, 5, so 5.962 is the answer. So you'll be able to add or subtract decimal numbers, and if you convert them to like decimals it will be more easy for you. It will be convenient for you to do the operation. Now after studying all about decimals, now we will be able to identify a decimal number. We know what is a decimal number, isn't it? It's a fraction. So it's a part of a whole. It's not whole, it's a part of a whole, or a whole plus a part. Okay, so now we should be able to tell where these decimal numbers are applied in real life. So where do we see these decimal numbers? Can you just imagine where these decimal numbers are applied in our real life? Yes, so whenever we measure something, whenever we measure some quantities, we can say them in decimal numbers. Or the very most common thing we see decimal numbers in real life application is rupees and pies. So while writing rupees, so we say 20 rupees and 50 pies. So that is written as 20.50 rupees. 20.50 can be written. That is 20 rupees and 50 pies can be written as decimal numbers. Then how do we measure? I told you, while measuring quantities or while converting the units from smaller unit to bigger unit, we'll have decimals. So how do we do them? See, 2 kilometers, I can write it as 2000 meters. Okay, so that is easy. 2 into 1000 will give you 2000 meters. Upon conversion, because 1 kilometer is equal to 1000 meters, I can write it as 2000 meters. But how do I write 245 meters as kilometers? See, this is from smaller to bigger, from bigger to smaller. From bigger to smaller, you just need to multiply the conversion factor, BSF. Bigger to smaller unit, you need to multiply. From smaller unit to bigger unit, what you need to do? You need to do division, that is SBD. Just remember the mnemonic, BSM and SBD, it will be easy for you while converting. So bigger to smaller, we just multiply it. So there is no question of getting a decimal number or a fraction while converting big unit to smaller unit, because we are multiplying. But upon converting smaller unit to bigger unit, you need to divide. So when we start dividing, the question of fractions and decimal numbers arise. See, 245 meters, how do we convert to kilometer? We know the conversion factor from kilometer to meter is 1000, isn't it? So smaller to bigger, we need to divide. So how do we divide 245 divided by 1000? So see, this is exactly what we did before, because 245 divided by 1000, now we know how to convert this into decimal, isn't it? So we have 3 zeros here, so just write 245. Now since there are 3 zeros, from right start moving left 1, 2, 3 places, put a point here. So 0.25 kilometers. So this is your answer. So 0.245. See how easy it is. After understanding what are decimals and how to convert fractions to decimals, or how to make a number while converting units, we can, how to convert them into, how to convert smaller unit to bigger units. So this will be easy for us now. Okay, you will be understanding more easily after doing all those fractions to decimals. It will be easy for you. So now 0.245 kilometer, we can represent even meters, even smaller units in bigger units using these decimal numbers. Okay, so that's it for this chapter, decimal numbers. In the next class, we'll be quickly seeing some important problems, or a problem in each and every type in this chapter, and we'll move on to the next chapter after that. Okay, hope you understood this chapter very well. So keep practicing. We'll do some problems in the next class, and until I meet you in the next class, it's bye from Anu. Thank you.